Hello friends, good evening all of you. Today's session we are going to see about combinational circuits. Actually we have started sequential and combinational last class. So combinational itself we have a different types actually. So that is called already I said it's a half adder, full adder, half subtractor, full subtractor like this, binary adder, subtractor. So these are the concept we have in these combinational circuits. First of all, combinational circuit means actually so no memory needed. Actually, suppress it will take a present input and it will provide this and do calculations. Okay. Now today we are going to see about binary adder subtractor. So we can move on to the topic. So first one, binary adder, n-bit parallel adder. So here a binary adder is a digital logic circuit used to add two binary numbers. It performs what is a arithmetic addition in computers and digital systems. So a half adder, what will happen? Yesterday we have seen the last class, what is half adder and full adder. Even subtractor and full subtractor also we have completed. So half adder means adds only two single bit binary number. Full adder means what? Adds two single bit binary number along with the carry input. Means three inputs. Half adder two inputs, full adder three inputs. To add multi-bit binary numbers, for example, actually 1 plus 1, this is called half adder. Suppose 1 plus 1 with carry, this one just I am taking means this is full adder. Suppose I want to add like this numbers, for example, some multi-bit binary numbers means this is called binary adder. So here full adders are connected together. So multiple full adders is connected together. We are going to see the diagram also now. So this arrangement is called n-bit parallel adder. Okay. Now, why it is called a parallel adder? When adding a two n-bit binary numbers, all corresponding bits are supplied to the full adder simultaneously in parallelly. So each full adder calculates a sum bit while the carry propagates off one stage to the next. So here first n full adders are connected in series. The carry out or C out on the full adder becomes carry in the next full adder. So while seeing the diagram, you can understand well still. Now we can see one example. For example, A 1011. Okay, and B 0101. So here I need for this one I need one full adder, this one I need one full adder, this one I need one full adder, this one also I need one full adder. Okay, this is the concept. We are going to see the diagram also. Now we can add it both the things. What will we will get the answer? Just for carry, just you can assume that just it will be 0 carry. So 1 plus 1 what? 10. So 0 here, 1 it will come here. So 1 plus 1 again 10. Here 1 it will come 1 here. 1 plus 1 again 0. Here 1 it will come. And 1 plus 1 again 0. Here 1 it will come. So you can see here sums everything. Here you can see this is 111. Just you can see how what is the 16 answer. Yes, actually 15 what? This is called 15. Yes. What about 16? This is called 16 actually. Suppose if you don't know table, just we can identify through this also. 2 power 0. This is 2 power 1. This is 2 power 2. This is 2 power 3. This is 2 power 4. So what is 2 power 4? 16. That's all. Okay, this is the answer actually we get. The same thing they have given in the table also. For example, you can see MSB means this is called MSB. This is LSB. Most significant bit and LSB least significant bit. So here A value what? 1. This is next to 0. This is 1. This is 1. B value what? 0. This value will be 1. This is 0. This is 1. Actually, this is same thing they have done in the table also. But just table format they have given. Okay. So carry what I return here. This is the carry they have given. And this is called actually sums they have given. Okay. So this is performing just addition. You can see working principles. What is working principles? So the first full adder add the least significant bit. So that is called, this is called least significant bit. Yes. So it will add from here actually they are telling. So now it generates a sum and carry. Yes. So the carry is passed to the next full adder. So this is first full adder. It will add to the, it will generate a sum and it will generate a carry also. This joined together, it will do next full adder. This is called next full adder. Okay, every full adder repeats the process. The final carry becomes most significant bit of the results if present. So advantages faster than adding one bit at a time. So for example, we are adding one bit means it will be very difficult. So automatically we'll get it will be fast to compare this one. So simple hardware implementation, easy to extend 8 bit, 16 bit, 32 bits, and as well as 16 bit adders or 64 bit adders also. So widely used in CPU, ALU, and digital processor. So disadvantage, ripple carry delay. So each full adder must wait for the carry from the previous stage. Because once it's completed full adder, first full adder only, that carry it will forward it to the next full adder. So it has to wait for the output. Okay, to get the inputs. As the number of bit increases, the maybe total delay also it will increase. So that is the disadvantage. Okay, this is the diagram you can see. First one I'll show you 1 0 1 1 0 1 0 1 we have taken. Yes, actually this is called A0. A0 means this is A0. This is A1. This is A2. This is A3. This is the meaning actually we have to understand. This is B0. This is B1. This is B2. This is B3. Okay. Now what A is a 0, 1. This is 1. So carry just simply we have to take 0. Now 1 plus 1 what? Carry 0, carry 1. Sum will be 0. Okay. So 1 plus 1, 0, carry 1. So this carry 1 here forwarded. Now next one what happened? This one plus this one. This one, 3 inputs we have to take for full ladder. This is one input, this is one input, and this is one input. What about A1? This is 1, B1 0, this is 1, C1 1. So 1 plus 1 0 here, carry 1. So carry 1 it will goes. So again here A2 here 0, B2 1. So this 1 plus 1 10. 10 means carry 0 forwarded to 1 here carry. So again A3 what? 1. B3 B3 what? This is called I think 1. Sorry 0. So this one and this one you can add it 10. So this is called 0. This carry will be 1. So totally I'm getting 1. This is 0 0 0 0. This is my answer. So last slides we have seen the same thing. So diagrammatic. So this is called binary and binary adder. Okay. So next one we are going to move. It's a binary subtractor. Binary adder subtractor. So this is a combinational circuit that can perform both addition and subtraction of binary numbers using the same hardware. That is important. So here we are using full adders, XOR gates, and mode control input. So because it has to change the mode depends on that it will work out whether adder or subtractor. M equal to 0 means it will work out adding, and M equal to 1 means it will add, it will do subtraction. So like that it will work out depends on the mode control. So so basic idea, subtraction in the digital system is performed 2's complement method. I'll tell you first one, 2's complement. Suppose for example, I want to change this number as a 2's complement means first we need to change as a 1's complement. What is 1's complement? The same number we have to negate opposite terms we have to write. 1 for 0, 0 for 1, 1 for 0, 1 for 0. Now 2's complement means we need to add 1 here. So 1, 0, 1, 0. So my 2's complement for this number 0, 1, 0, 1. Okay, this is the format we have to do 2's complement. Okay, so instead of building separate subtraction, add normally for addition 2's complement subtraction. That we'll see in the example itself. Okay, now first one, for example, I am giving 1 0 1 1 0 1 0 1. So this is I'm giving for binary adder subtractor means actually. So this is called addition, not a problem. With the same concept we can do. M equal to 0 means automatically it will move on to the addition and will work out. But subtraction means for this per one, this is called A, and this is called B, means B it will take 2's complement. So first one we will see what is this number, what is the number? This is 2 power 0, this is 2 power 1, 2 power 2, 2 power 3. Yes, so this is called 8 plus 2 plus 1. This is 11. Okay, so 11, yes. Now this is what? This is 2 power 0, this is called 1, 2 power 1, 2 power 2. So 4 plus 1, 5. So I have to get 11 means I have to get 6. This is my answer I have to get. Subtraction means. Now we will see how we are going to get the value. First one I have to take B's 2's complement. So 0, 1, 0, 1. What is the 2's complement? First we can take 1's complement. 1, 0, 1, 0 negation. Next to 1, 2's complement means what I said. For this number I have to add 1. So 1, 1, 0, 1. Okay, now we have to add A plus B. A value what? 1, 0, 1, 1. And next what value we got? 1, 0, 1, 1. So what we are getting? 1 plus 1, 0. Here 1. Triple 1 what? 11. So 11 here. So 1 carry. So 1. So 1 plus 1, 0. Actually that carry just we have to ignore it. Now what answer we got? 6 we got answer. So 11 minus 5 equal to 6. So this is the method it will do binary subtraction. Okay, so binary subtraction, this is the same concept they have given. So XOR gate means subtraction, just it's going to complement. So after that, so 5 plus 3 means actually 5 plus 2's complement of 3. Sorry, 5 minus 3 means 5 plus 2's complement of 3. That is the meaning actually. Okay, so the binary adder subtractor is a special type of circuit that is used to perform both operations like addition and subtraction. So the operation which is going to be used depends on the values contained by the control signal. That's very important. So control signals depends on the M mode control. It will work out whether this is addition or this is subtraction. And to work out binary adder subtractor, it requires we have the XOR gate form. So we have to understand what is XOR gate also. Okay, now we can see the diagram. So first one, it will take this Cin and here it will work out the XOR this one. It will change the mode, whether this is 0 or 1, whatever depends on that. It will work out addition or subtraction. Okay, so while doing subtraction, it will take XOR gate second value. So this is the meaning it's working. The same thing, for example, we have done, sorry, this example also. 6 plus 3. M equal to 0 means it will work out 6 plus 3 what? 9. For example, 0, 1, 1, 0, 0, 0, 1, 1. So here 1, 0, 0, here 1. What is the value? This is 9. So 9 we got. That is correct. Now 6 minus 3 means what we have to get? We have to get 3. So what is the process we have to do for this concept? A plus B. B is a 2's complement. Then so now you can keep it A the same number. First B we can change 2's complement 0, 0, 1, 1. Then we can take 1, 1, 0, 0. This is 1's complement. We can add it 1, 0, 1, 1. Now we can add 0, 1, 1, 0 with the 1, 1, 0, 1. Now we can add it 1, 1, 0. This is 0. This is 1. You can carry just to ignore it. This value is called what? 3. So we got 3 value. Okay. So this is the method we have to do, binary subtraction method. Just the diagram we have to know we are using XOR gate. It's more than enough. Okay. Now simple questions we can see depends on the concept. The binary adder subtractor performs subtraction by using 2's complements of B. Simple questions only, but we have to know, we have to understand these things also. And in a binary adder subtractor, this is a PYQ. The XOR gates are used to what? Generate a carry? No. So this complement the second operand. Okay, this is the meaning. XOR gate, why we are using in the adder subtractor? It will complement of the second operand. Next one, the mode control input M equal to 1 means. Already I said actually M equal to 0 means that is called adder, and M equal to 1 means it will do subtraction. Yes, now M equal to 1 they have given, so automatically it will be a subtraction. Now you can see A equal to 1 0 1 0 they have given. B is equal to 0 1 and 0 1 they have given. Now M equal to 0 they have given. 0 means what operation they have to do? It has to do. That is called addition. So automatically you can do add 1 1 1 1. So this is my answer. So depends on the control signal. It will binary add or subtracted. It will work out the uh, this adder or subtractor. Which one? Okay. I hope today's concept of full and full only binary adder subtractor only. So tomorrow we are going to see about decoder, encoders, multiplexer and demultiplexers, and about the previous questions also depends on the concept. Okay, thank you all of you. Thank you once again.